We look at writing quadratic equations in different ways, including the factored and the standard form, and the same thing can be done for linear equations. A common way to write the equation of a line is slope-intercept form. Point-slope form is similar, and it's one we're going to spend quite a bit of time on. And then finally, we'll take a small detour to standard form, or rather we'll see what happens when we're given standard form and then convert it to slope-intercept form. All right, so in slope-intercept form, that's our y equals mx plus b formula. As I mentioned, m is always the slope. So m is whatever number comes before the x, the coefficient of x. B is the y-intercept. That means that b, or rather the point 0b, is where this straight line will cross the y-axis. In point-slope form, we again have our slope as m, but in this case, we indicate one point that we'll find on this line. The x and the y are the same x and y that are here. Those are the variables that we're showing the relationship of. Essentially, the point-slope form is just the slope formula rearranged. Let's start with slope-intercept form. We have two different questions here. We're first asked to find the equation of the line with these given parameters, and then we'll draw its graph. All right, so we're told that the line has a slope of -2, so m is equal to -2, and a y-intercept of -3, so b is -3. We're in slope-intercept form, so the formula we're looking for is y is equal to mx plus b. Now we simply substitute in the information given. So y is equal to -2x plus b, and b in our case is -3, so -3. And this is enough information to graph the line. In order to draw a graph, we just need 2 points or 1 point and the slope. In this case, we have 1 point, a specific one, the y-intercept, the point 0, -3, and the slope of -2/1, or -2. So we start with the point, 0, -3. So there's our point, 0, -3. It's where we cross the y-axis. It's the y-intercept. Now we'll use our slope to find one more point. Because we know we have a straight line, we're told we have a straight line, we know that we only need one other point in order to graph it. So we'll use the slope, rise over run, to find that second point. So starting at the y-intercept, we see that we have a rise of 2. I'm going to choose to go up by 2. Let's stay here. And now our run is 1. Because I have a negative slope, I have to move to the left. My second point is -1, -1. So we connect those with a straight line and carry on to the edges of our coordinate plane. And there's our first graph. Notice that I decided to go up for the slope. I could just as easily have started at the point 0, -3 and gone down for a rise of -2. In that case, in order to make sure that I have a line that has a negative slope, I now have to go to the right by 1 step. So I tend not to memorize whether negative means up, down, left, or right, but I choose to go up or down by whatever is most convenient, and here both are quite possible, and then determine whether I go left or right based on whether my slope is negative or positive. Here's a very similar question. The meat of this question is that we're asked to give an equation in point-slope form. However, I'll show you how to convert this to slope-intercept form as well. We'll then graph the line. And the fact that we're given 2 points to start with means that we can actually go ahead and graph it first. Whether you're writing the equation in point-slope form or in slope-intercept form, you're going to need the slope. So let's start with that. And slope is y2 minus y1 over x2 minus x1. So I like to go ahead and label my points. This will be x1 and y1, and x2 and y2. Now I can just plug those in to the equation. So I have -3 minus 5 divided by 2 minus 4. In other words, negative 8 over negative 2, or a slope of positive 4. Now we'll look at the point slope form. Formula looks like this. Y minus y1 is equal to m times x minus x1. So choose one of your points, either 4, 5 or 2, negative 3 to be the point that you'll use. Since I've already labeled 4, 5 as x1, y1, let's go ahead and use that one. And we just calculated m, the slope. So we end up with y minus 5 is equal to 4 times x minus 4. And that's the final answer in point slope form. There's nothing else that we need to do here. And in fact, now that we have the slope and a point, we can go ahead and graph this line. And in fact, since we have 2 points, I could just go ahead and use those 2 points to create the graph. Here they are, connecting them with a straight line, gives me the graph of that line. All right, the last thing this question asks us to do is to also write the equation in slope-intercept form. Now there are 2 ways that we can do this. I've just rewritten our equation in point slope form here and reiterated that we know that the slope of the line is 4. So the first method to write our equation of a line in slope-intercept form is to start with the point slope form and solve for y. In other words, take the point slope form and rewrite it so that it's in the form y equals mx plus b. We'll start by using distributive property to undo the grouping. If y minus 5 is equal to 4x minus 16. I want to isolate y, have it on its own on the left-hand side. So I'll move the negative 5 over to the right-hand side by adding 5 to both sides. That gives me y is equal to 4x minus 16 plus 5. And finally, we find that y is equal to 4x minus 11. So now we've actually clearly indicated what the slope is once again, and also found the y-intercept. A second way to write the equation of a line in slope-intercept form is to start with the slope, choose one point, one xy coordinate, and use these 3 pieces of information, the m, the x, and the y, together with the equation for the slope-intercept form to solve for b. So I'll substitute in 5 for y. So I could use either point here. 4 for the slope, of course. 4 for the value of x. And I'll solve for b. If 5 is equal to 16 plus b, moving 16 over to the left by subtracting 16 from both sides gives me 5 minus 16 is equal to b. And finally, b is equal to negative 11. All right, take a step back. So I know that the slope, m, is equal to 4. The y-intercept is equal to negative 11. Once again, the goal here is to write the equation in the form y equals mx plus b. So keeping the y and the x to show the relationship between y and x, but replacing the slope and the y-intercept with their actual values, we find y is equal to 4x minus 11. The same answer that we found previously. Let's try one more, just because the information is provided a little bit differently. So we're asked to find again the equation of a line, but the line we're interested in is perpendicular to this one. So I'll call this line 1. I notice that for line 1, the slope, I'll call this m1, is equal to negative 2 over 3. Since the line we're interested in drawing is perpendicular to line 2, I'll call the one we're interested in line 2, its slope must be the negative reciprocal. So the slope of the line we're going to draw, and whose equation we're going to write, is positive 3 over 2. Our y-intercept is again given in relation to a second line. So we want the same y-intercept as y equals 4x minus 3. I'll call this line 3. So for line 3, what is our value of b? Our value for b, it's already given in slope-intercept form, is -3. So for line 2, the one whose equation we're trying to write will have the same y-intercept. Didn't specify how we should write the equation here, so since we're given the slope and the intercept, I'll use slope-intercept form. So I'll rewrite it in y equals mx plus b form, in other words. So we have y is equal to 3 over 2x minus 3. I'll use that same information, the slope and the y-intercept, to draw my graph. Once again, I'll start with the y-intercept. In this case, 0, -3. It's a coincidence that it's the same value as we've seen previously. And then I'll use the slope to find a second point. So here's my starting point, 0, -3, and my slope is 3 over 2. So I can either go up or down 3. I'll choose to go up, 1, 2, 3 points, and then a run of 2 for a positive slope means I have to go 2 steps to the right. So there's my second point. Alternately, I could have chosen to go 1, 2, 3 steps down first, but then I would have had to go 2 steps to the left to ensure that positive slope. Connect the dots here with a straight line, and we're done. Finally, let's have a look at the equation of a line that's given in a different form. This is standard form, 2x plus 5y plus 10 equals 0. So we have both variables as well as a constant on the left-hand side, and the line is set to 0. If we're asked to find the slope and the y-intercept of the line, the easiest way to do this is to rewrite the given equation in y equals mx plus b, or slope-intercept form. So the first step to solve for y is to move the other terms, the positive 2x and the positive 10, to the right-hand side. Because both 2x and 10 are positive, we'll move them by subtracting them from both sides. This gives us 5y is equal to -2x and -10. I chose to write the term with the x first because I'm aiming for y equals mx plus b slope-intercept form. I want to see the term with the x immediately to the right of the equal sign. All right, one more step to isolating y. Y's problem is that it's being multiplied by 5, so we're going to divide both sides by 5. Let's just cancel the 5's from the left-hand side, and we find that y is equal to -2x minus 10 over 5. Now, that's a pretty clumsy way to write that. If I take the entire right-hand side and divide by 5, that's the same as taking each term separately and dividing it by 5. So I'll rewrite this as -2x over 5 minus 10 over 5. Think of subtracting those two equations. Because they have the same denominator, you're allowed to do the subtraction, and the line previous to that is exactly what that would look like. All right, so it's still not quite in the form we want. We'd like the x to not be in the numerator with the 2, so we'll just separate them. We'll write this as -2 over 5 times x, which means exactly the same thing, minus 10 divided by 5, minus the simplified fraction, minus 2. All right, the slope, -2 over 5, and the y-intercept is -2. Let's use that information to draw our graph. Let's graph the point that we know first, and that's the y-intercept. Again, in other words, the point 0, -2. That's right down here. And then I'll use the slope, m equals -2 over 5, to find a second point. The rise is 2, so I'll go up 2 spots, and then I have a run of 5. If I go to the right, my line would have a positive slope, so I'd best go to the left. So there's the second point. Again, if I had chosen to go down 2 steps first, I would now have had to move to the right for my second, or in this case, a third point. Now we connect the dots. And there we go.